Good evening, algebra students. Mr. Lawrence here with your next flipped lesson. Now, I gotta tell you, those of you that are watching the videos, shh, don't tell the kids who are refusing to, because we're having a quiz tomorrow. Yeah, I'm expecting this to be Monday the 17th, and we're having a quiz tomorrow. And I'm going to tell you real quick, the quiz is going to be very much like the last quiz. It's going to have order of operations, a little bit more involved order of operations problems, a little bit more challenging ones, some easier ones. But then it's also going to have stuff like solving equations, just plain old two-step, and solving equations where you have variables on both sides. So those of you watching the videos, you can go ahead and review if you need to, and for the rest, it's going to be a nice surprise. Anyway, let's get on with today's lesson. So today we are solving equations with fractions. It's another multi-step type equation. And these first two examples here, 1 and 2, these really aren't what the lesson is about. They do have fractions in them, but these are really just 2, or maybe number 2 is a 3-step equation if you want. I can do it in 2, but you might not be comfortable enough with fractions yet to do it in 2. So I'm going to do them the long way. So number 1, if we have x over 2, or x divided by 2, minus 5 equals 3. We're just going to treat this like a regular 2-step equation. Saddam is going to tell us to undo the 5 with addition, right? Yikes. And then we're going to end up with x over 2, and that's going to equal 8. And then to undo the addition or multiplication here, undo the division, we're going to use multiplication. Now I got to warn some of you. Some of you are putting the 2 in the denominator when you multiply. You really can't do that. I mean, you can't do this, x over 2, and then go times 2, because that would equal x over 4. There's no canceling going on. So don't do that, all right? So what happens over here? We have to multiply the right-hand side by 2. Don't forget to do that, Mr. Lawrence. Now that one I can do just like that because they're both in the numerator, right? Okay, so these 2's cancel out. Excuse me, my left-hand side becomes x, and my right-hand side becomes 16. And there you go. All right. Now over here on number 2, again, it's really just a 2-step equation. You might call it a 3-step. If you're really good with fractions, and I'll mention it because if you are good with fractions, you might want to try it. First of all, because of Saddam, I will subtract 1. I undo the equation in the reverse order of operations, which would really be the best way to say that instead of saying Saddam, but I like Saddam. It's a catchy little phrase, but if you're on the OA, you're going to say the reverse order of operations. Okay. Now, I'm going to do it. I know I have 2 operations going on here. I have multiplication there, and I have division here with this fraction bar. So I'm going to get rid of the division first by multiplying. And then I got to multiply this side. And so this will end up with my left-hand side looking like plain old 2x because the 3 is canceled. And my right-hand side is 9. And now it's just a 1-step equation. I'll divide by 2 on both sides and get the result that x will equal 4.5. And notice I didn't go decimal on that. I'm not going to be a fraction wimp. I'm going to use fractions as much as possible because second semester we are going to do some really ugly problems. And if you're not good with fractions, if you're always running into decimals, you won't be able to do these problems. You won't have the understanding that you need. Okay, now I wanted to mention something really quick. I had said that I could do this problem in 2 steps. So I'm going to pretend we're back at this step. We've already done the subtracting 1 from both sides. And now, instead of multiplying by 3 and dividing by 2, I am going to multiply the whole fraction by 3 over 2. In which case I have to do it here, times 3 over 2. And I'll put that over 1. Now, the cool thing is, the 3's cancel. and the 2's cancel, and I'm left with just a plain old x. On this side, I don't see anything that's going to cancel. I'm going to do 3 times 3 is 9. 1 times 2 is 2. And then x is going to equal 4.5. All right. Now, you don't have to do it this way, but I wanted to mention that I would have done it this way because I'm really good at fractions. As we get further along, I'll expect you to kind of drop the baby step in the first way I did it and move on to that, but not yet, unless you're comfortable. All right, these are the problems that the lesson is about. And I want to point out to you that my first step in problem number 3 will not be to subtract 4. I can't do it. This denominator of 3 is going into the 2x. He's also going into the 4. So in a sense, there's really not a 4 in the problem. It's a 4/3. I mean, if I really wanted to, I don't want to, but I'll do it for you. Right? I could rewrite that fraction like this. Those mean the same thing. And when I do that, you can see that there's not a 2 in the problem. It's a 2/3. There's not a 4 in the problem. There's a 4/3. Now, I'm not going to do it that way. I'd rather do it this way. I'm going to, first off, get rid of this division. This divided by 3. To get rid of division, Anna knows. She's going to say, hey, Mr. Lawrence, I think you should multiply. And Anna, you are just so smart. All right. So I do this. My 3's cancel. And I'll be left with 2x plus 4 on the left-hand side. The right-hand side is the hard side. 7 times 3 is 21. And now we're at a 2-step equation. And so I'll subtract 4 from both sides. I'll end up with 2x equaling 17. And then x, of course, will equal 8.5. All right, I will take 17 over 2 as an answer, but I don't want you giving it unless you understand what you're doing. By the way, did I mention there's a quiz tomorrow? Okay, so number 4. My first step is to get rid of this denominator. Why? Because he's mucking things up. He's keeping that 5 and negative 2x bound together. So I'm going to multiply because the fraction implies division. So I'm going to multiply both sides by the denominator. And that will allow me some freedom doing the hard side first. And then on the right hand or the left hand side, the 4's look like they're going to cancel. And then I'll have 5 minus 2x. Now be careful here. I've got to get rid of this 5, but it's a positive 5, so I will subtract 5. Right? That negative, it belongs to the 2x, not to the 5. So the inverse operation is going to be subtraction, not addition. My right-hand side becomes 19. My left-hand side, don't lose this little negative guy. Negative 2x. Don't lose the negative. He's got to come down. All right, and now I'm going to get ready to divide. I'll divide by negative 2 on both sides. And then x will equal 9 1/2. And I've made a mistake. Did you see it? It should be negative 9 1/2. I'll bet Alexis saw that. She's just so smart. All right, let me see here. Problem number 5, very much the same thing. Again, I have to get rid of the division first because it's bound to the 2 terms in the numerator. Now, if you wanted to, you might be able to just divide in, 6 divided by negative 2 and negative 10x divided by negative 2. You can do that. That's a great way to do it, and that will accomplish the same thing. But since we're teaching it this way, I'm going to go ahead and do this. And let me see here. I'm going to multiply by negative 2. And Brad could have told us that we had to multiply by negative 2 because it will cause my denominator to cancel. In effect, it will undo the division that's going on in the problem. And then I'll bet you Mr. Gray could tell you the right-hand side would be negative 20. And let me see, who could tell me the left-hand side? Oh, I'll bet you Nathan could. Nathan will know that'll be 6 minus 10x. All right, and now it's just a two-step equation, so I'm going to subtract 6, and notice I didn't draw attention to where the sign was. I've already learned that the negative belongs to the 10. So to undo the 6, I need to subtract 6 because I want them to turn to 0. Okay, so I end up with the left-hand side of negative 10x, the right-hand side of negative 26, divide by 10, divide by 10. X ends up equaling a negative 2 and 3/5. How did I get that? Well, it would be 2 and 6/10, and then I simplify. Right? Now, I know a lot of you will give this as an answer. And I will give credit as long as you put x equals in there. I'll give full credit. It's an okay answer, but I want you to stop running to decimals every time you do a problem. All right, I think this video has gone long enough, but I think it's worth it for those of you who heard about the quiz tomorrow. And Mr. Lawrence will now sign off. Have a good night, everybody.